Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Today I will be demonstrating the storage type sprinkler. Okay. If you are unfamiliar, feel free to keep watching to learn more about it. Okay. And if you have not already watched my previous tutorial, I recommend checking it out first. That way you will have a clear idea. See, many people are familiar with basic firefighting system calculation. Okay, but I would like to shed light on a storage type sprinkler system in this video and also in upcoming video. Okay, I will explain all the storage type sprinkler including ceiling sprinkler and rack type sprinkler and their calculation. Okay, so without wasting time, let's start. See, everyone knows that light hazards, ordinary hazards 1 and 2 and extra hazard 1 and 2, okay, and their calculation. Okay, but the storage type sprinkler is different from this type of occupancies. Okay, see, in a storage type, what means a storage? Where we store the materials, okay, that type of warehouses, okay, we call a storage, and in that storage type we don't use like normal sprinkler, okay, we use a special type sprinkler which called a storage type sprinkler. Okay, so that type of sprinkler here categorized in 4 types. Okay, see, in this lecture we will calculate water demand calculation, okay, using this CMDA, CMSA, ESFR and a special approach, okay, as per NFPA 13 chapter 24. A special type approach, it means extended coverage area sprinkler. Okay, so see, and also we will cover the rake sprinkler. Okay, see, the storage type sprinkler normally we use in a storage this only 4 types of sprinkler. Okay, first one is CMDA, second one is CMSA, this is type of sprinkler, okay, don't be confused, and ESFR, and one is extended coverage, okay, a sprinkler. Here see, CMDA, CMSA, ESFR and extended coverage area, okay, using alternative approach. So firstly we have to see the example one. Firstly we have to familiar that which type of storage we are going to design. Okay, see, we already know that I am going to design a storage type, a storage warehouses. Okay, here is storage warehouses, right? So second one, we have to select that which type of sprinkler we are going to install. Okay, on that basis only we can calculate all this hydraulic calculation and all this calculation, okay, related to design, right? So we know that the storage warehouse we are going to design. Okay, so in a storage, see, in a storage we use, if the material which is stored is kept on the pallet, okay, so we use the ceiling sprinkler. Okay, you know, here here, see, suppose like this is our storage, right? If our material is kept here, okay, on the pallet, right, wooden pallet or what type of pallet is kept here, so we will use here a sprinkler, right, on the ceiling of the warehouses. Okay, so this type of sprinkler we called ceiling type sprinkler, right? So we use two types of sprinkler. One is ceiling type sprinkler, and if the material is stored on the rack, right, one side rack, two rack system, okay, rack, so we have to use ceiling sprinkler and as well as the rack sprinkler. Okay, so firstly I will explain about the ceiling sprinkler, right? See, here is the four types of sprinkler. We will see one by one that which type of sprinkler we can use as per the occupancies. Okay, and which one is good, then you can select for your design. Okay, all type of four type of sprinkler we can use in storage, but we will see what's the difference. Okay, so the storage warehouses, we know that we are going to design. Second one, what type of material is kept in that warehouse, we have to select their commodities. Okay, see, class 4 platize, it means the material is kept on the pallet. Okay, and class 4, from where we know that class 4, which class the material comes, material will come in which class, we don't know, commodities. Okay, so already I mentioned here that table A20, if NFPA 2019, we will go here. See, just copy this one, I'll show you here. This is NFPA 13 2019 edition. We will see this table is commodity classes, right? If the material is stored the battery, okay, and which type of battery, dry cell battery, vehicle or vehicle large or vehicle small, on that basis we can define our classes here. Okay, see, class 1, class 1, class 4. Okay, if the container, if in a warehouse, if it is kept container, okay, jar, container, you know, then it will come like this, class 4. Okay, bottles or jar, and in that one is material is kept inside, that it will come in class 4. Okay, so remember this table, and whatever the storage is stored in the warehouses, we can define accordingly their classes, right? I hope it's clear, you're not confused about the classes. Okay, see here, so suppose I already selected our class. Okay, class 4 and platize. So height of storage, the material store is 30 feet. Okay, but height of warehouses up to the ceiling is 35 feet here. Okay, so and we are going to design weight system, right? So we will see all these four options. If we are going to use CMDA sprinkler or any other sprinkler, then what is the difference? Okay, suppose first one here, firstly we will see if we are using CMDA sprinkler, then how much water it will take. Okay, see here, with CMDA sprinkler, okay, now we will see the NFPA 13 2009 chapter 21 clause number 21.2 figure 21.2.2. okay, this is the figure, you can cross check in NFPA 2013 19. Okay, figure already I attach here. Okay, so if we are going to design, so see, already I select, then class 4. Okay, so class 4 here. Okay, 0. Okay, so if we are going to select high temperature rated sprinkler, then this curve, this figure we will use. Okay, and if we are going to select ordinary temperature rated sprinkler, then this table we will use, right? So suppose I am going to use high temperature rated sprinkler. Okay, because it will be more in warehouses. Okay, so it's better to, for safe side, we are going to use high temperature rated sprinkler, uh, and also it's depend on the project. Okay, so here high temperature rated sprinkler, suppose I'm going to use. Okay, so class 4, right? Class 4, our occupancy is class 4 here. So here, okay, the density will be 0.3. Okay, it's clear. And the area of a sprinkler operation will be 2000 square feet, right? It's clear. There is no any doubt. With this with the help of this figure, we can easily select. Firstly, we determine the class, and according to the class we can determine the density. Okay, sprinkler density and their area of operation. Okay, so only we have to design 2000 feet square, right? But remember, this figure is only up to 20 feet. Okay, on that 20 feet height. Okay, on that 20 feet height this figure is created. Okay, but our storage height here, our storage height is 30 feet, right? And ceiling height is 35 feet. So we have to adjust this graph according to our heights. Okay, because this graph is made only taking the reference of 20 feet. Okay, so see here density is, we already select 0.30 30. Okay, and area of operation is 2000 square feet. Okay, and we have to adjust our density, this density, according to our height. So this graph, also this graph is mentioned in NFP 2019. Okay, on that same chapter, on this same chapter. Okay, you can cross check. I already cut this figure and paste here. So here see how here a storage height is 30 feet, right? So according to 30 feet, this is the percentage of design curve density. Okay, so 30 feet is storage here, and on that what is the percentage density here? It will come 190, right? It means 190%. Then when we'll convert 190% into point, see here, 190 and percent, right? So it will come 1.9, and 1.9 multiply, right? Here what is our actual density on the basis of 20 feet height is 0.3, right? So our new density will be 0.57. So that's why here mentioned 0.57 per square feet, right? So now it's clear that whatever the storage height, we can adjust our density. Okay, so I already got here 0.57 GPM per square feet is our density. Okay, now next, here already I got the sprinkler. Okay, this is a sprinkler density and their area of operation. Okay, now we have to add the hose allowances. Okay, so see table 12.2.6, remember this table. Okay, you can take the screenshot. On that basis, the hose stream allowance also we have to add in our calculation. Okay, so we are using CMDA sprinkler here. Okay, so CMDA sprinkler, if you will see, and class is C1 to 4, so our commodity class is 4, so also it will come in that categories. Okay, and a sprinkler spacing type standard and extend. Okay, whatever the, but we are using a standard, so also it will come in this point. And other one is size of design area at ceiling. Okay, so our area of operation is 2000 feet square feet. Okay, so here see third one 1500 up to 2600 feet. So on this category our area of operation will fall, right? So we select this one. And hose allowances, then how much we will take? 500 GPM. Okay, and time 120. Okay, now already I got how much allowances we have to take and their time. Okay, so now we will calculate here. See, a sprinkler demand, area and density, right? What is here? See, the formula is Q is equal to A into D, right? Is equal to P and under root P root, this is the K. Okay, K root P, right? This is our formula. So what will be our GPM? Area into density. What is area? 2000 and density is 0.57. Okay, okay, so the sprinkler GPM we already got this one, this much, and hose demand we add 500 GP. Okay, then total will be 1640 GPM. And what is the time? Up to 120 minutes we have to take, so we will multiply 120 and total GPM will come this much gallon. Okay, and also here the density is, see, the density is greater than 0.3. okay, so remember, if the density will be greater than 0.3, then the sprinkler we will select, their K factor will be more than 11.2. okay, more than 11.2, remember. So here we select 11.2, we can select, or more than, so 16.8. okay, so what will be their pressure, minimum pressure, because we need to calculate the hydraulic calculation, the minimum pressure. Okay, so 11.2 if we select. And what is the coverage area of one sprinkler as per the extra hazard, because all the storage type sprinkler we calculate as per the extra hazard. Okay, so the area of operation of one sprinkler will be 100 square feet. Okay, so here Q is equal to A, okay, under root P, right? So if 11.2, okay, multiply root P, you know, and Q here here Q we know A into D. The A 100 square feet into D. What is the D of one sprinkler? 0.57, right? Here, right? So the next will be 57 is equal to, or 11.2 is equal to under root P. Okay, by calculating this, see, I show you here. 57 divide 11.2, okay, and multiply 2 times. Here 11 that 57 divide 11.2, okay, this much, and square 25.9, it means 26. Okay, so 26 psi. Here it's come 26 psi. If we convert, then it will come 1.8 bar. So minimum pressure we required at the last of the sprinkler should be 26 psi. Okay, accordingly, if we are going to use the sprinkler which K factor is 16.8, then minimum pressure we have to manage 11.5. okay, so I hope it's clear now, and if you have any doubt, then you can comment below. Okay, and this series will be continue. Okay, next we will see the CMSA sprinkler. Okay, after that ESFR, and more video will come. Okay, all the storage type sprinkler we will see. Okay, thank you very much. Assalamu alaikum warahmatullahi wabarakatuh.